Hello dear learner, today we are going to learn about wind energy. First of all, we will talk about wind energy. So first question is that what is wind? Wind is air in motion. Wind is mainly formed due to Earth's rotation and the uneven heating of Earth's surface by sun rays. The sun rays cover a much greater area at the equator than at the poles. The hot air rises from the equator, expands towards the poles, causes wind. Pressure introduction. First, we will see that Earth is wrapped in a blanket of air called atmosphere, which is made up of several layers in gases. Air has weight and it exerts pressure. Example, empty bicycle and tube light lighter pressure than tube on increases air pressure point. In horizontal distribution, distribution of atmosphere pressure over the globe is known as horizontal distribution of pressure. It is shown on maps with the help of isobars. An isobar is a line connecting points that have equal values of pressure after being reduced to sea level. Now, pressure belts, distinctly identifiable zones of homogeneous 7 pressure belts are there. There are two types of cells around the global atmosphere circulation. First one is Ferrel cell and second one is Hadley cell. In this figure, we can see that the global atmosphere circulation. As we know that wind is air in motion, air is set of motion due to the diameter differences in atmosphere pressure. Wind blows from high pressure to low pressure. Types of winds. Winds can be classified in 3 types. First one is primary winds, which is also known as permanent, prevailing or planetary winds. The second one is secondary winds. It covers the seasonal wind or monsoon. And third one is tertiary wind, which is called as local wind. The main effect of wind is defined by Coriolis effect. The rotation of the earth causes all moving objects in the northern hemisphere, including air mass, to deflect to the right and those in the southern hemisphere to move to the left. The Coriolis effect is absent at the equator. Coriolis forces presents a direct simple flow from the equator to the poles. This is also known as Fresnel's law. In the image, you can see the basic fundamental of Coriolis effect. These are some factors which governing the pattern of planetary winds. First one is latitudinal variation of atmospheric heating. Second, emergence of pressure belts. Third one is the migration of belts following apparent path of the sun. Fourth one is the distribution of the continents and oceans. And the last one is the rotation of earth. Now we talk about the origin of winds. The origin of winds may be traced basically to uneven heating of the earth's surface due to sun. This may lead to a circulation of widespread winds on a global basis, produce planetary winds, or may have a limited influences smaller areas of cause local winds. The wind from the heat motion to energy. As we can see in the picture, the radiation from sun has covered 3 main topics. First one is heat, second one is pressure gradient and third one is motion. And we have also discussed about the Coriolis acceleration or Coriolis effect. The last one is large scale global wind system. We will talk about these topics one by one. First of all, wind turbine power, which is given by wind power equals to 1 by 2 rho A Cp into V cube. Here P equals to power in watts, rho equals to air density, which is about 1.225 kilogram per meter cube at sea level, less higher. A equals to rotor swept area, which is denoted in meter square. Cp is the coefficient of performance that is decided by the Betz limit, which is equal to 0.59, the maximum theoretical possible. V equals to wind speed in meter per second. We can say theoretically 20 miles per hour equals to 9 meter per second. In this particular image, we will talk about the drag and lift forces and pitching moment on stationary airfoil. Here you can see the left lift forces, which is perpendicular to the airfoil, and drag forces, which is plane to the airfoil, and alpha equals to angle of attack, and C equals to chord, which is near around 0.97. Now, Windrose diagram. Windrose diagram indicates the frequency of wind direction and intensity. Here you can see in the example that winds predominantly from south, west, northwest and northeast, and strongest wind from south, due west, northwest and northeast. Here is the example of Windrose diagram, from where we can see the frequency and wind direction intensity from particular site. Here are the classes of wind power density at a 10 meter and 50 meter range. Here you can see that different parameters of classes are defined in the table. Wind power classes are defined in 7 categories, and these categories are different for 10 meter height and 50 meter height. So, simultaneously for wind power density in watt per meter square and wind power density for watt per meter square are different in the case of 10 meter as well as different in the case of 50 meter due to lower height and higher height. Now, the benefits of wind power. First one is the environmental benefits: no emissions, no fuel needed, distributed power and remote locations. Now, we talk about the advantages of wind energy. Wind energy is an inexhaustible source of energy and is virtually a limitless resources. Now, second one is energy is generated without polluting the environment. Third one is this source of energy has tremendous potential to generate energy on large scale. That is why the reason that our southern part of India is benefited from the wind energy. Fourth one is, like solar energy and hydropower, wind power laps a natural physical resources. And the last one, without generate, don't emit any emission that can lead to acid rain or greenhouse gas effect. Now, we will talk about the limitation of wind power. Power density is very low in the case of wind energy. So, it needs a very large number of windmills to produce modest amounts of power. Cost is very high because the wind manufacturers are mainly the technology comes from the abroad, and presently we are working on the cost issue in India also, to reduce cost issue actually. Now, the environmental cost, material and maintenance cost is very high. noise, birds and appearance is one of the major factor for the case of limitation. Cannot meet large scale and transpiration energy needs. So dear learner, now we discuss about the disadvantages of wind energy. Wind energy requires expensive storage during peak production time. The next one is, it is unreliable energy source as winds are uncertain and unpredictable. Third one is, its visual and aesthetic impact on region is not very much clear. The last one is, the wind plant require large open area for setting up a wind farms. Now we talk about the wind turbine noise levels. In the picture you can see that the different noise levels are defined. Now we talk about the future of wind energy. The future of wind energy can be bright if government policies subsidize and encourage its use. The next one is, technology improvements unlikely to have a major impact. And the last one is, wind energy can become cost competitive for electricity generation if fossil energy cost skyrocket. Thank you.